Hello everyone. Yesterday we have discussed about the chemical properties of alkali metals. Some of the chemical properties of alkali metals we have discussed. And today we continue with the same chemical properties of alkali metals, some other properties. Okay. Now see. Generally, the chemical properties of alkali metals are due to different types of what here reasons we discussed now. What here due to presence of only one valence electron. Due to presence of one valence electron, they are highly electropositive and lose electron easily. Because of that, they are having what now more reactivity, and they have low ionization potential. That's why they lose electrons easily and exhibit what more reactivity. Now, some of the other reactions are see the normal oxides like monoxide M2O. Example what Na2O. The normal oxides react with water, react with the H2O, react with water to form what hydroxides. Hydroxides means what here like NaOH. When Na2O dissolves in water, we get NaOH. See M2O when reacts with when dissolves in water, we get MOH. That is what hydroxide. The basic nature of oxides increases gradually on moving down the group. On moving down the group means what now here? Lithium oxide and cesium oxide. So which is most basic? Which is most basic here? So it is most basic. Okay, more basic is what here? Cesium oxide. Among the monoxides, among the monoxide normal oxides of alkali metals, which is more basic in nature, the cesium oxide is more basic in nature. So from lithium to cesium down the group, the basic nature of all oxides will be normal oxides will be increasing. Next, the hydroxide MOH, the hydroxides are colorless. The hydroxides are colorless solutions. Why colorless? The reason is that here M plus like Na plus, okay, has how many electrons? Na plus has how many electrons? 10 electrons. 10 electrons means what? 1s2, 2s2, 2p6. 1s2, 2s2, 2p6 for this 10 electrons. So 1s2, 2 electrons paired, 2s2, 2 electrons paired, 2p6 also. All the electrons are paired. No unpaired electron is there in Na plus. In M plus cation, no unpaired electrons. When there are no unpaired electrons, we have to say colorless solution is formed here. So NaOH and KOH, all these hydroxides of first year group solutions are colorless because the cations are having all electrons paired, means they are not having any unpaired electrons. Next, the hydroxides are strong alkalis, alkaline nature, strongly basic in nature. They are more basic in nature. And corrosive compounds. Suppose NaOH is there. NaOH is corrosive compound. Corrosive means what? It will corrode the walls of stomach. If you consume NaOH, suppose, if you consume NaOH to neutralize the HCl acid in stomach, to neutralize HCl acid in the stomach, if you consume NaOH base, suppose, then it will corrode the walls of stomach. That's why we should not use NaOH. Strong base should not be used as the antacid. Antacid will neutralize what? The excess acid in the stomach. So NaOH cannot be used for the antacid, as antacid. Okay, because it is corrosive. NaOH, corrosive compound it is NaOH. And these are soluble in water. These means what here? Hydroxides. The hydroxides are soluble in water. Here M plus cation is there, OH minus anion is there. So the hydroxides of first year group elements are soluble in water and dissolve with, and they dissolve with evolution of heat. Means evolution of heat means exothermic or endothermic. They are exothermic. So when you dissolve NaOH in water, when you dissolve KOH in water, heat energy is released. That means what? The process is what? Exothermic process. Exothermic dissolution we say. Okay. Next, the hydroxides are thermally stable. Thermally stable means what? On heating also, they will not decompose. NaOH is thermally stable, meaning what? On heating NaOH, it will not be dissociated. It will not be dissociated. So it is called thermally stable compound. Except what? Except lithium hydroxide. That means lithium hydroxide will dissociate. On heating, lithium hydroxide will decompose into the compounds, but NaOH, KOH, RbOH, all these compounds do not dissociate. They are thermally stable compounds. Okay. Next, the relative strength of hydroxides. The relative strength of hydroxides increases from lithium hydroxide to cesium hydroxide. Now here, if you take cesium hydroxide and lithium hydroxide, which is more stable? The cesium hydroxide is more stable. So we can say it is most stable hydroxide of first year group, most stable we say, and most basic means most alkaline. Most basic means what? Most alkaline substance among these hydroxides here. So most stability will increase from lithium to cesium, and basicity, basic properties, basic nature also will increase from lithium to cesium. That point we have to understand. Next, the crystal structures of Li2O, Na2O, K2O, and Rb2O are anti-fluoride type of structures. Anti-fluoride. The name you remember. These all structures we'll study in lesson what? Solid state lesson. In solid state lesson, we discuss all these things. Already we have discussed what gaseous state and liquid state. Gaseous state, liquid state completed. Then we have to discuss what solid state, which comes in second year. Okay, in +2 intermediate second year, this topic is the solid state. There we will study about all these crystal structures. Just for time being, remember that the mono oxides, the normal oxides of lithium, sodium, potassium, rubidium, all these will be having which structure? Anti-fluoride structure. That point keep in mind. Next, cesium monoxide. The normal oxide of cesium has an anti-CdCl2, means cadmium chloride. Here anti-fluoride here, but here anti-cadmium chloride type of structure. It is layered structure. So cesium oxide has anti-cadmium chloride type of structure, but remaining oxides have anti-fluoride structure. These names only remember for time being. These all things we'll study in detail in solid state lesson. Okay. Next, the higher oxides. The higher oxides, namely VIZ means what? Namely the higher oxides, namely peroxides and superoxides. Peroxides and superoxides are strong oxidizing agents. They are strong oxidizing agents. Suppose you take here Na2O2, sodium peroxide formula what? Na2O2, peroxide it is. Peroxide example what? Na2O2. And superoxide for example what? KO2. Superoxide is what? KO2. So potassium superoxide and this sodium peroxide. These are called generally higher oxides. Now it is what now? Sodium monoxide is lower oxide, but here sodium peroxide is higher oxide. Potassium oxide is what? Lower oxide, but potassium superoxide is higher oxide. So the higher oxides, namely peroxides and superoxides, are strong oxidizing agents. Strong oxidizing agents meaning what? They undergo what? Reduction. They undergo reduction. As they're undergoing reduction, they act as what? Powerful oxidizing agents. They undergo reduction. That's why they act as what? Oxidizing agents. So they easily undergo reduction. They easily undergo reduction. That's why they act as what? Powerful oxidizing agents. That point keep in mind. Next, they react with dilute acids. The higher oxides. They means what now here? Higher oxides. The higher oxides like peroxide and superoxide. The peroxide and superoxide will be reacting with dilute acids, forming hydrogen peroxide. So sodium peroxide will change into hydrogen peroxide. The sodium peroxide will change into what? Hydrogen peroxide. So the higher oxides react with dilute acids, forming hydrogen peroxide and oxygen respectively. Now see, suppose you take here Na2O2, sodium peroxide will be giving hydrogen peroxide, and KO2 will be giving oxygen. KO2 will be giving, superoxide will be giving oxygen, and peroxide will be giving hydrogen peroxide. Like this, suppose you say, take the reaction of Na2O2 with H2SO4. It is dilute H2SO4. Dilute H2SO4 versus Na2O2, sodium peroxide. Sodium peroxide it is. Now this sodium peroxide is interacting with dilute H2SO4 acid to give what? Na2SO4. Here Na plus ions and SO4 minus 2 ions. The Na plus ions will combine with SO4 minus 2 to form Na2SO4. Na2SO4. Sodium sulfate is formed. The oxidation state of each sodium is +1. The oxidation state of SO4 minus 2 is what? -2. Means this is called charge. The charge on sulfate radical is -2 here. Then we got H2O2. H2O2 is what? Hydrogen peroxide. What is the name of this? Hydrogen peroxide. So this hydrogen peroxide structure we have to remember. So here O bond O linkage is called peroxy linkage. This is called peroxy linkage. And it is 1H. It is 1H. So this structure is called what, ma? The structure of H2O2. This is called open book structure. What we say? This one? Open book structure. So H2O2 has which structure, ma? Open book structure it is. Okay. Now here oxygen has 2 bonds around it. This oxygen has 2 bonds around it. And here 2 lone pairs will be on this oxygen. 2 lone pairs will be on this oxygen. Okay. So each oxygen has got 2 lone pairs. And this bond is between 2 different atoms now. So it is what now? A polar bond. What is? Polar bond. So why OH bond is polar? The bond, the covalent bond between 2 different atoms, 2 different electronegative atoms. So it is polar bond. Here partial negative charge on oxygen, partial positive charge on hydrogen. So it is polar bond. Positive pole is the negative pole is. That's why it is polar bond. And the bond, this covalent bond is between 2 same atoms now. That's why it is called non-polar covalent bond. So non-polar covalent bond. Why this O single bond O is non-polar? The covalent bond between same atoms, na? So it is non-polar. Between 2 different atoms, it is called polar. So polar, how many bonds there? 2 OH polar bonds there. And 1 O single bond O non-polar bond. And this linkage, O single bond O linkage is called peroxy linkage. So like this hydrogen peroxide is produced here. Next, now here see. K2 is what now here? Superoxide, potassium superoxide. Potassium superoxide when interacts with dilute H2SO4, we get oxygen here, remember, not hydrogen peroxide. What we get? Oxygen we get. Oxygen gas is obtained when potassium superoxide reacts with dilute acid, dilute H2SO4. Here K plus will interact with SO4 minus 2. Then we get potassium sulfate, K2SO4, K2SO4. Then instead of H2O2, what we get? H2O and O2. H2O and O2 we get. Is that clear, ma'am? So in this way we have to understand. Now tell me here in this superoxide, O2 minus 1, right? Superoxide means what here? O2 minus 1. Then each oxygen is having what now? Each oxygen is having how much? Minus 1 by 2. Minus 1 by 2 is the oxidation state of each oxygen. For 2 oxygen atoms, minus 1. Then for each oxygen, how much? Minus 1 by 2, isn't it? So now here minus 1 by 2 is the oxidation state of each oxygen atom here. For each oxygen, minus 1 by 2. Right, ma'am? Now you take here oxygen has got what? Each oxygen has got minus 2. Here also oxygen has got minus 2. Right, ma'am? So here what is happening is that this O minus, O with negative charge is going to what? O0, you see. 0 is there now. Here oxygen molecule means 2 atoms. Each atom will be having 0 charge. So here minus 1 is going to 0. Minus 1 is going to 0 means what, ma? It is undergoing what? Increase in the charge. And minus half is coming to minus 2. Minus half is coming to minus 2. So here 0 charge, minus 1 by 2, minus 1, minus 2. Now from minus 1 by 2, it is decreasing to minus 2. When the charge is changed from minus 1 by 2, from minus 1 by 2, the charge is coming to minus 2, right? See, minus 1 by 2 is coming to what? Minus 2. That means decreasing or increasing? The decrease in the charge is called what? The decrease in the charge is called what? Reduction. Decrease in the charge is called reduction, isn't it? So now here one point what we have studied here, they're acting as oxidizing agents means they're undergoing what? Reduction. They're undergoing what? Peroxides and superoxides are easily undergoing what? They're undergoing what here? Reduction. Reduction meaning what? Decrease in the charge. See, minus 1 by 2 of superoxide is going to minus 2. That means what is happening? Undergoing reduction. So as this compound is undergoing reduction, as this compound is undergoing reduction, it acts as which agent? Oxidizing agent. Therefore, oxidizing agent. So what is oxidizing agent here? KO2. Potassium superoxide is what here? KO2 is what now? Oxidizing agent, because it is undergoing a reduction. It is reducing, it is getting reduced from where to where? -1/2 to -2. This point we have to clearly understand. Is that clear, ma? So it is about this one. Now next one here, KO2. KO2 means again what? Superoxide, potassium superoxide. When it interacts with H2O, in this case now, when it interacts with water, here dilute acid, na? But here we are taking water, KO2 plus H2O we are taking. In this case, in H2O, what will be there? In each H2O, 1 H plus. In 2 H2O, 2 H plus and 2 OH minus. 2 OH minus and 2 H plus will be in water. Now K plus ions will take OH minus. Yeah, 2 K plus ions there, na? 2 K plus ions will take 2 OH minus to form 2 KOH. K plus 1, OH minus 1. And next one here, 2 hydrogen atoms, 2 hydrogen ions are there here. And here 2 into 2, 2 into 2, 4 oxygen atoms there. 2 hydrogens and 4 oxygens here. And anyhow, OH groups are released here. So we get what now here? H2O2 and O2. Remember, H2O2, hydrogen peroxide and O2. Okay. So here what we have to understand is that sodium peroxide is giving only H2O2. And potassium superoxide is giving only oxygen with dilute acid. But the same potassium superoxide with water is giving H2O2 as well as O2. H2O2 and O2 gas. So this point we have to understand. Next one. The peroxides are diamagnetic in nature. The peroxides are what? Diamagnetic. Diamagnetic in nature meaning what? Repelled by magnets. Repelled by magnets. If any substance is repelled by magnets, that is called diamagnetic. Or if any substance is attracted by magnet, weakly attracted by magnet, it is called paramagnetic. Paramagnetic substance and diamagnetic substance. Diamagnetic substance meaning what? It will be repelled by magnets. So the peroxides are what? Diamagnetic in nature. That is, all the electrons are paired. All the electrons in peroxides are paired. There are no unpaired electrons. As there are no unpaired electrons, it will be diamagnetic in nature. And are regarded as what? The salts of the dibasic acid. The peroxides are regarded as what? The salts of dibasic acid. Example of dibasic acid, what? H2SO4. In H2SO4, how many H plus ions there? 2 H plus ions. One molecule of H2SO4 can produce how many H plus? 2 H plus. That's why it is called dibasic acid. As it is able to produce 2 H plus ions, it is called dibasic acid. Okay, basicity of this acid is what? 2. Basicity of this acid is 2. That is N factor. N factor of this H2SO4 is 2. Because it is producing how many H plus? 2 H plus. One H2SO4 molecule is able to produce 2 H plus ions. So N factor we say. N factor is equal to 2 here for H2SO4. This N factor is also called for acids basicity. The basicity is equal to 2. That's why this acid is called dibasic acid, H2SO4. So what we have to say that the peroxides are what now here? The peroxides are what now? The salts of dibasic acid. Peroxides are considered to be salts of dibasic acid. Okay, next one here, that is H2O2. H2O2 also dibasic here. H2O2 also dibasic. So each H2O2 can produce how many H plus totally? 2 H plus. So what is N factor here? N factor of H2O2 2. That's why this H2O2 acid also is called dibasic acid. From this we are getting Na2O2. From H2O2 we can get Na2O2. So Na2O2 will be regarded as what? The salt of dibasic acid. Next one, the superoxides are paramagnetic. The superoxides means what? KO2. Here O2 minus 1, K plus 1. So this O2 minus 1, O2 minus 1 is superoxide ion. The superoxides are paramagnetic. Why they are paramagnetic? Because unpaired electrons will be there. Unpaired electrons. So due to unpaired electrons, they will act as what? Paramagnetic substances. The superoxides. Paramagnetic meaning what? Attracted by magnets. Attracted by magnets. And they are colored. Colored means what now? Again, unpaired electron. Again, due to unpaired electron, they will be colored. Okay. As odd electron bond is present between two oxygen atoms. Between two oxygen atoms in superoxide, odd electron bond will be there. I told you. Between two oxygen atoms in superoxide, one covalent bond will be there. Along with this covalent bond, there will be odd electron bond. The 3 electron bond is called odd electron bond. So the odd electron bond. So what is here? Odd electron bond. So this odd electron bond is this one here. This is odd electron bond. Due to this odd electron bond, one electron is unpaired here. These two are paired, one electron unpaired. This unpaired electron will make it paramagnetic. This unpaired electron will make the superoxides paramagnetic and also colored. Due to odd electron is present between two oxygen atoms in superoxides. Then yellow color of Na2O2 is probably due to the presence of small amount of what? Superoxide. Actually, Na2O2 pure compound is colorless. Pure Na2O2 is what? Colorless. Colorless. Why it is colorless? All electrons are paired. All electrons are paired. When all electrons are paired, there won't be any color. When electrons are paired, there won't be any color. Okay. But actually, the pure Na2O2 is colorless. But Na2O2 sample, Na2O2 with superoxide impurities. So when superoxide is present as impurities, okay, when superoxides are present as impurities, that will be giving which color? Yellow color. The yellow color of peroxide. The yellow color of Na2O2. The yellow color of Na2O2 peroxide is due to what? The superoxide present it as what? Impurity. The superoxides will be present as impurities in peroxides. Then Na2O2 will be giving which color? Yellow color. Once again, this point. Yellow color of Na2O2 is probably due to the presence of what? Small amount of superoxide as impurity. And superoxides are even stronger oxidizing agents than what? Peroxides. Both are oxidizing agents. Both are oxidizing agents only, superoxides and peroxides. Between superoxides and peroxides, which will be powerful oxidizing agents? Superoxides. So superoxides are powerful oxidizing agents. That means what now here? Powerful oxidizing agents means they easily undergo what? They easily undergo oxidation or reduction. They easily undergo the powerful oxidizing agents. Oxidizing agents will undergo what? Reduction. They easily undergo reduction. They can easily undergo reduction. That's why they act as powerful oxidizing agents. Okay, ma? So between superoxides and peroxides, which oxides will easily undergo reduction? Tell me. Between superoxides and peroxides, which will undergo reduction easily? Superoxides will undergo reduction very easily. That's why they are more powerful oxidizing agents than what? More powerful oxidizing agents than peroxides. So lastly, one point what you have to remember without confusion is that between superoxides and peroxides, which oxides are more powerful oxidizing agents? Superoxides. Next, reactivity towards halogens. Halogens means what are they? Halogens, fluorine, chlorine, bromine, iodine. And astatine we don't take. Astatine is unstable, means radioactive in nature. So fluorine, chlorine, bromine, iodine take. Halogens. X means halogen. So reaction of these alkali metals towards what? Towards what? Halogens. Towards the Halogens. So halogens are what now? Fluorine, chlorine, bromine, iodine. Now see, the alkali metals directly react with halogens, forming halides, forming the halides. Directly reacting meaning what? Without any heating, without any external heating, directly they will be converted into halides. Okay, halide ion is what? X minus. Like chloride ion is what? Cl minus. So halides will be produced here of the type Mx. Mx means what? M plus and X minus. X minus ion is called what? Halide. M plus ion is what? Alkali metal cation. So like this, the two alkali metal atoms. Okay, each atom zero charge. And here each halogen atom zero charge. In halogen molecule like Cl2, in a halogen molecule like Cl2, each atom will be zero charged. Okay, and here now M plus M0 is going to M plus 1. M0 is going to M plus 1. Now 0 to plus 1 is called what, ma? 0 to plus 1 is called increase in the charge. Increase in the charge means what? Oxidation. So this metal is undergoing what? Metal undergoes oxidation. Metal atom undergoes what? Oxidation. Therefore, the metal acts as what now here? Metal M acts as which agent? Reducing agent. Reducing agent. Why the alkali metal is reducing agent? Because it undergoes oxidation from 0 to plus 1. Next, halogen, you see, halogen initially has what? 0. Now finally it is getting minus 1. Now 0 to minus 1 means what? Decrease in the charge. Decrease in the charge is called what? Reduction. Okay, the halogens undergo what? Reduction. When they undergo reduction, they act as what? Oxidizing agents. The halogen acts as what? Oxidizing agent. So halogens act as what? Oxidizing agents. And alkali metals act as what? Reducing agents. Is that clear, ma? So halogen is oxidizing agent because it undergoes reduction. Like this, MX type of halides will be forming. Metal halide will be forming. Like NaCl. Example what? NaCl, Na plus Cl minus. Is that clear? Next one, the reactivity of alkali metals towards a particular halogen. The reactivity of alkali metals towards a particular halogen increases from lithium to cesium. So cesium is what now here? More reactive metal. More reactive metal. More reactive metal towards what? Halogens. On the other hand, the reactivity of halogens towards a particular alkali metal decreases from fluorine to iodine. Now here in this year, among the halogens, which is more reactive? Halogen. More reactive. Now tell me, why fluorine is more reactive? Since fluorine is what? More electronegative. More electronegative. So fluorine is more electronegative. That's why more reactive. And if we take cesium, why cesium is more reactive? Since cesium is what? More electropositive. More electropositive. So as cesium is more electropositive, as cesium metal is more electropositive, it is more reactive. Cesium is more reactive because the cesium is more electropositive metal. Is that clear, ma? So this point very important to understand here. So what is to be understood is that lithium to cesium reactivity from top to bottom in the first year group, reactivity decreases or increases? Reactivity decreases or increases, no? Reactivity increases. That means what now here? Cesium has more reactive. Cesium is more reactive. So lithium to cesium from top to bottom in the group, first year group, the reactivity will increase. The reactivity will increase because the electropositive character increases. Metallic nature increases. That's why more metallic cesium is more reactive. But if you take halogens now, if you take halogens, fluorine to iodine, now what happens now? Reactivity will decrease or increase here? Reactivity decreases. Among the halogens, reactivity decreases. Why reactivity decreases here among the halogens from top to bottom in the group? Because electronegativity decreasing. Electronegativity decreases from top to bottom in halogens, among the halogens. Therefore, reactivity of halogens will decrease from fluorine to iodine. Whereas in first year group, in alkali metals, among the alkali metals, lithium to cesium, the reactivity increases because electropositive character increases. So this point we have to understand now. Next, with just a moment. Now here, so with the exception of certain lithium halides means LiX, with some exceptions of certain lithium halides, the alkali metal halides are ionic compounds. They are ionic compounds like NaCl, KCl. All these are what? Ionic compounds. Exception what here? Exception what? Lithium chloride is covalent compound. Lithium chloride is what? Covalent compound. So the lithium, the first element of alkali metals, shows what? It shows anomalous properties. Anomalous properties means different properties from other elements of the same group. Anomalous properties. That's why lithium halide is what now? Covalent compound. Whereas the other halides of the same group will be ionic compounds. Next, the halides are crystalline and have high melting and boiling points. The NaCl, all these are what here? Crystalline. They have crystal solid type of structure. About the crystalline structures, we study in which lesson I told you? Solid state. In solid state, we study about crystal structures of solids, ionic solids. Remember for time being that the halides are crystalline in nature. They have crystal structure and have what? High melting point and boiling points. The fused halides. Fused means what? Molten. Fused meaning what? Molten. The fused halides meaning molten halides are good conductors of electricity and heat. And they are used for the preparation of alkali metals. For the extraction of alkali metals, we use what? Fused. We use fused halides. Molten halides will be used. Like from molten NaCl. From molten NaCl, we get sodium. Okay, from molten NaCl, we get what? Sodium alkali metal. Like that. Next, all halides except lithium fluoride dissolve in water. That means LiF is not soluble. LiF is not soluble in water. Not soluble in water. So except lithium fluoride, remaining all will be soluble in water. The reason is what now? The lithium fluoride has greater lattice enthalpy. Lattice enthalpy. The lattice enthalpy will be greater for lithium fluoride. Lattice enthalpy means what? The energy required to break cation anion. To break the cation and anion, how much energy is required is called what? Lattice enthalpy. That lattice enthalpy is very high here. Because of greater lattice enthalpy, it will not dissociate into Li plus and F minus, and dissolution does not take place. Okay. Next. Alkali metal halides. Alkali metal halides are colorless. Colorless means always what we have to recall? There are no unpaired electrons. Okay, but on heating, they turn yellow, sometimes blue. On heating, they turn what? Yellow and blue. Due to owing means what? Due to. So due to owing means two should not be there. Owing itself is what now? Due to. Okay, so they will give sometimes what now here? Alkali metal halides sometimes will turn into yellow and blue color due to non-stoichiometry and crystal defects. Again, the non-stoichiometry of the ionic compounds and crystal defects of the ionic compounds we study in which lesson? Solid state. In the solid state we discuss. Just remember that alkali metal halides like NaCl, are colorless. But on heating, they will turn what? Into yellow and blue color. Due to what? Non-stoichiometry or crystal defects. That all we will discuss in solid state lesson. Okay, reason only remember for time being. Halides of potassium, rubidium and cesium have a property of combining with extra halogen atoms. Halides of potassium, rubidium, cesium have a property of combining with what? Extra halogen. Okay, forming polyhalides. Now a potassium iodide is what now? Halide of potassium. Halide of potassium, example what? Potassium iodide. It when it reacts with iodine, it will form Ki3. In this Ki3, what is cation? Tell me. K plus is cation, I3 minus is anion. This I3 minus has sp3d type of hybridization and linear shape, linear geometry. Do you remember from chemical bonding topic we discussed? I3 minus is linear shaped species and has what? sp3d type of hybridization. So I3 minus is anion here and K plus is cation here in this compound. So this is called potassium polyhalide, potassium triiodide, polyiodide. Okay, next. The insolubility of lithium fluoride. I told you, na, lithium fluoride has what? High lattice enthalpy, therefore, and less solubility and zero solubility in water. Why zero solubility in water? Because of greater value of what? Lattice enthalpy. Already we discussed. The insolubility of lithium fluoride in water can be explained in the following manner. The lithium ion, Li+, lithium ion has the highest energy of what? Hydration. Hydration energy will be greater. Smaller cation will be having hydration enthalpy greater. As it's small in size, as it is small in size, it will be having greater hydration enthalpy in comparison to other alkali metal ions. In comparison to Na+, K+ and all, Li+ has small size and thus it should have high solubility generally. When hydration enthalpy is greater, solubility should be greater actually. But here, however, the small Li+ and F- ions interact very strongly. Both are small here, lithium plus small, F- small. Both interact very strongly, resulting in high lattice enthalpy, high lattice energy of lithium fluoride, which is responsible for its insolubility in water. That reason we have to remember.